I had become aware of the fact that cancer is largely, not totally, but largely a disease associated with aging. The hypothesis that I started working on was, were there things in our environment that were playing a role in the increased incidence of cancer that we see happening in our population? It got me into the areas of endocrine disruption. And I think it's important to realize that while in adults, for example, as an adult woman, let's say you have too much estrogen, may be associated with some health problems, or too little, but it's adjustable, relatively reversible in adults. But during development, our endocrine system is absolutely essential. And if it's not functioning appropriately, whatever happens is not going to be reversible.
So today we are going to talk about environmental pollutants and their impact on our health, some of the latest research, and maybe figure out what we might be able to do to minimize the problem, minimize our own individual health risk. Hello and welcome to the Enjoy Life Healthier podcast. I'm Jason Campbell. We have another fascinating guest on today. We are being joined by Dr. Linda Birnbaum, Ph.D. Dr. Birnbaum is a distinguished American toxicologist and microbiologist with a career spanning over 4 decades in environmental health research. She served as the director of the National Institute of Environmental Health Sciences and the National Toxicology Program from 2009 to 2019. She oversaw a budget exceeding $700 million dedicated to understanding how environmental factors influence human health and disease. So today we are going to talk about environmental pollutants and their impact on our health, some of the latest research, some of the things we may need to worry about the most, and maybe figure out what we might be able to do to minimize the problem, minimize our own individual health risks. So I want to jump right in here and welcome Dr. Birnbaum on board. Doctor, welcome to the show.
Well, thank you, Jason. I'm very happy to be here and happy to talk about what I see as some of the biggest environmental health threats we're dealing with.
Well, great. Well, why don't we start off? I'll let you tell us about your background and what drew you to the field of environmental health research.
My background was that my Ph.D. says microbiology. It was really molecular biology before many of the tools that have enabled it to move forward so rapidly occurred. And I decided, after doing kind of molecular genetics and mapping some genes in a bacteria, I decided I wanted to move into the big time. So I started to work with yeast. And from that, I'm one of those people who kind of follows my nose. When there's something that looks interesting, I move forward. And I had become aware of the fact that cancer is largely, not totally, but largely a disease associated with aging. It goes up with about the power of 4 with aging, the incidence of cancer. And the hypothesis that I started working on was, were there things in our environment that were playing a role in the increased incidence of cancer that we see happening in our population? And that kind of led me to move kind of from molecular biology and biochemistry into more pharmacology. And my husband and I were living in upstate New York, which is very beautiful a couple of weeks of the year, but it was very cold and very long winters, and we decided we kind of wanted something. And I was able to get a tenure-track position down at the National Institute of Environmental Health Sciences in North Carolina, in a new program which evolved into the National Toxicology Program. And literally, I had to look up what was toxicology because I didn't know. But that's how I kind of really got into environmental health in detail, because my first projects were assigned to work with some very toxic and very persistent chemicals. People have heard of TCDD or dioxins or PCBs, and that's what I started working on. And my career just kind of blossomed from there. I was able to get tenure at NIEHS, spent 10 years there, and then was recruited to head EPA's largest health research division, also in North Carolina. So that was a benefit of being able to make a major career move without moving my family. And I spent almost 19 years at EPA looking at issues of air pollution, which affects nearly everything, liver and kidney toxicity and effects, and also at the impacts on the immune system. And that also kind of led me to work in areas with certain environmental chemicals that people are all aware of, like asbestos. But also, it got me into the areas of endocrine disruption. And I think many people think of our endocrine system and they think of estrogens and testosterone and maybe thyroid hormone. Well, those are but three of the kinds of hormone systems we have. And I think it's important to realize that while in adults, for example, as an adult woman, if you don't have enough, or let's say you have too much estrogen, may be associated with some health problems, or too little, but it's adjustable, relatively reversible in adults. But during development, our endocrine system is absolutely essential. And if it's not functioning appropriately, whatever happens is not going to be reversible.
So in terms of endocrine disrupting chemicals or compounds, where are these coming from? Where are they found? Is it drinking water? Is it the air? Is it the products we, live with? Is it all of the above? What really is the problem?
Well, I think the problem with many environmental chemicals is they're everywhere and in all of us, at least at certain times in our life or at certain points. So I'm not sure people understand or realize the fact that since really the 1950s, there have been nearly 400,000 unique chemicals that have been synthesized, and they've gotten into the environment. Some of them then get altered in the environment to something else, and we know very little about most of these chemicals. When we talk about endocrine disrupting chemicals, many chemicals will impact with one or more endocrine systems, often at very, very low levels in the environment. And what happens when you are exposed to these things is very dependent upon not only how much you're exposed to, but when are you exposed to it. As I mentioned before, is it, for example, early in life, before you're born as a fetus or as an infant, or maybe as an adolescent? We all know that adolescence is not the most stable period in our lives. And in fact, so that you can perturb things then, during pregnancy is a time of increased susceptibility, not only for the growing fetus, but for the mother as well, because her body is changing. And then obviously, in the elderly as well. So I think the point is that there are so many chemicals out there, and we know a lot about very few.
And where do you think we're most exposed? You tend to think of drinking water. I live on Long Island here in New York, and it's said that the drinking water does have chemicals in them. I guess I'm not sure if you've ever looked at our local region and if that's actually true or not. But is drinking water a problem?
I think drinking water can be a problem. I think, there are tens of millions of people in the U.S. who are on private wells, and those are not regulated in any way, shape, or form. You've got hundreds of millions of people on municipal water systems, and they have regulations for certain kinds of contaminants. But we're just beginning to get regulations for this class known as PFAS or PFAS. And in fact, there are at least 15,000 PFAS out there. And the regulations, which were finally finalized last April of this year, deal with 6 of them.
And what are the most dangerous chemicals that you see in drinking water?
Well, I think the PFAS are of great concern, not because they're going to cause you to turn over and die quickly, but because of the chronic exposure. Many of these compounds are persistent. All the PFAS are persistent in the environment. They're never going to leave the environment, but many of them are extremely persistent in our bodies. So they build up to higher amounts. The same kinds of things that we understood from the dioxin and PCBs. Now, PCBs stopped being made intentionally in this country in the late 70s, and yet every one of us still has PCBs in our body. Every one of us still has DDT in our body. That was, it was banned by a law of Congress in 1972 because of eggshell thinning of birds. The fact that eagles were not reproducing was of concern to our country. But we now know that there are many health effects as well. And even these chemicals were banned in 1972, we still have it in their bodies because how long they last in the environment and how long they last in us.
And so are they also in the food supply as well?
There are very few chemicals where you only have exposure from one place. So water is often kind of like the terminal place where chemicals end up. But the food supply, our land, our soil and sediment may be contaminated. Our food is a major issue for a couple of reasons. Going back to PFAS again, because that's a lot of work is being done on that class of chemicals right now, and there is growing concern. We know that, for example, biosolids, in other words, things that are used as fertilizer that are, for example, coming from sludge from municipal waste treatment plants, have been recommended and used as fertilizer. And now we know that, in fact, there can be lots of PFAS in that, which leads to contamination, not only of some of your, say, domestic animals, like cows or sheep, but also, for example, of the food supply that's grown there. So that's one source of food contamination. Another major source of food is, for example, packaging of food. And we know that that's a major problem because not only chemicals like PFAS, but some other chemicals like things like bisphenol. People may remember BPA, which was actually banned from baby bottles and sippy cups, in large part because young parents didn't want their babies being exposed to this chemical. And the more we study it, the more we find problems. But BPA, some of the phthalates, which are present, all of these things can be present in our food packaging materials. And this is something we can all do for ourselves. And I think that's a good thing to know about. Don't ever heat in plastic. Because when you raise the temperature, chemicals then move more and they migrate and they come out of the plastic and can get into your food at a much higher rate than they do sitting in the refrigerator or the freezer.
Do you think there's a problem? I mean, almost everybody drinks bottled water or water in plastic containers. How big of a concern is that in your view?
I think it's mixed. I think one of the things we're learning, the water in bottled water is often free of certain contaminants, but one of the things it does have, anything in plastic has the microplastics. And this may sound a little gross, but there are tens of thousands of microplastic pieces in a bottle of drinking water in plastic. And we all, maybe not all of us know, but we're all pooping out approximately a credit card's worth of microplastics every week.
Every week?
Yeah. We don't really know. The data we have is limited. We don't know whether these little tiny pieces of plastic are causing a lot of irritation, for example, in our GI tract. But we do know that chemicals that are in these microplastics are coming out and getting into our bloodstream. and therefore exposing the rest of our body.
Well, wow, what a project it would be to unwind this. I don't know what the I guess glass bottles,
Well, yeah, I mean, look, I think when we talk about major, huge environmental threats that I think people are becoming more and more aware of, obviously, today, I think most people understand climate change is a huge problem. I think the other is the issue of plastics. When plastics were kind of first produced, say in the 50s and 60s, they were miracles. We thought this was wonderful. But I would say that their overuse has created a huge problem. We all now try to recycle, but less than 15% of plastics are ever recycled, and those that are recycled can only be recycled once before they become too contaminated. When I remember when my babies were little, and if they had a bottle, the heavy baby glass bottles, they couldn't break. They didn't break easily. Years ago, everybody had, you put a deposit down on your soda pop bottles and you took them back to the store and got your deposit back. So I think the idea of moving away from single-use plastics especially should be a no-brainer. Every time you go to the store and you buy something and it's totally wrapped in like that hard plastic that you almost have to get a knife to get through, we don't need this, and we have to begin to understand what the impacts of this are.
So you mentioned definitely do not heat anything in plastic. What are some other practical tips that you would give people to minimize their overall exposure? What can we do, practically speaking, to try to reduce our exposure to some of these toxins out there?
So, for example, if you're on a municipal water system, every year you have to get a report of what are the contaminants in your water system. And if the contaminants are exceeding a regulatory guideline, or if it's something you're concerned about, get a filter. There are different kinds of filters that will remove different things. And some of the filter systems aren't terribly expensive. I think the best way to regulate is to have policy change. Relying on people to change their behavior it is much more difficult. I think when you can, to eat organic foods is a good thing to do, but not everybody can afford it, and not everybody has access to organic foods. And again, there's been several episodes that we found now in organic farms, say in Maine and some other states, where they have been using biosolids thinking that that was a really healthy fertilizer, and it turned out that they were contaminating their products with PFAS. So, I think the point is that there are many things that we're exposed to. We need to begin, I think, as a society, to ask the question, what do we need? What do we really need? Again, using PFAS as the example right now, I don't need to have my grandchildren's clothes stain repellent or stain resistant. I can wash them. I don't need my carpets treated with something to resist stain. Good old club soda works pretty well to get any kind of stains out. We have to kind of begin to think, where do we really need it? There may be some essential uses of certain chemicals and certain processes, but maybe there are things that we really don't need.
So if the United States did everything possible to try to address some of these important issues, put some new regulations in place where needed and so on, how much does that really stop the problem? In other words, how much of a global issue is this? If other countries, the Chinese or whoever aren't on board, would we really be able to move the needle?
So what I'm talking about are world problems. These are not unique to the United States. The EU, very honestly, is ahead of the US when it comes to testing and regulating pollutants. The Chinese have become aware of their problems and are beginning to deal with them. there are a number of international treaties, such as the Stockholm Convention, that deals with very persistent compounds. And unfortunately, not the United States, but well over 100 other countries have signed that agreement, and that is basically ban the production and use of a large number of these persistent chemicals. And that has been effective. There are all kinds of, for example, of pesticides that were made and extensively used in the 70s and 80s. They're not used anymore pretty much anywhere in the world. The PCBs haven't been made internationally anywhere for at least the last 30 years or so, or being used. There's certain other kinds of chemicals. So when if a chemical is listed in that treaty, it has international ramifications for the U.S. as well. I think in our country, we are very dependent on some of our states to kind of lead the way, with California being the 5th or 6th largest economy in the world. If you can't sell something in California, manufacturers are not going to make it anymore. So that's been a very effective, approach that has been used. And there are a couple of other states that have done that kind of thing. But I think the other thing we should be looking at is no one is exposed to one chemical at a time. We live in a soup of chemicals, and people are beginning now to try to study that complex, very, very complex mixtures to which we're all exposed. And when we start doing that, we often find that the term that's used is something from nothing. In other words, if you tested one chemical at a time, at the levels that people are being exposed to, you wouldn't see an effect. But in fact, when they're all put together, then you start seeing effects. So
I was just going to ask, sorry for interrupting, are there any good studies that show an actual health impact of either one or two chemicals, or like you said, chemicals in the aggregate? Is it really having, are there really consequences for health? Like, what are they finding?
Absolutely. Again, I think let's look at the health situation in our country right now. For infectious disease, we just came off a horrible pandemic. There may be another one that will happen, but we kind of know what you're supposed to do there and how to handle it. And when you're dealing with an infectious disease, you can see someone gets infected, they get sick, they get rid of the infection, they get better in general. The problem with environmental chemicals is that we're dealing usually with low-level chronic kind of exposures, and that's associated with chronic effects. So it's very hard to often say there's a smoking gun and I can clearly see the one-to-one relationship. But we can see in areas where there's increased pollution, or people have elevated levels of certain chemicals in their body, or we know that they're being more exposed. By doing observational human studies, we can show that there are effects. And when those epidemiological investigations show effects in multiple studies in different populations, for example, and then we have, say, animal toxicology studies that show something similar, and then sometimes we have mechanistic studies where we might use human cells in culture or animal cells in culture. When you put that all together, that begins to build the case that yes, that there are effects. So people understand today that cigarette smoking is associated with an increased risk of lung cancer, as well as many other things. But not everyone who smokes gets lung cancer. Okay? And that's because people have differential susceptibility. But say you're susceptible, or you're not susceptible to lung cancer, maybe you're susceptible to heart disease. So I think we also have to move away from what I would say is the drug principle of where you're looking for magic bullets, and realize that many environmental exposures are going to have the potential to cause effects depending upon how much, depending upon how long, depending upon, say, the genetics of the person, depending upon what else is there, that we may actually be able to see effects. So the epidemiology is very strong for things like, something like arsenic, lead, mercury, especially both regular mercury and methyl mercury. For your compounds, like there's growing data, for example, for BPA and for the phthalates, for the PFAS, we had lots of data for the dioxins and the PCBs and some of the insecticides and pesticides and herbicides. There are flame retardants. And that's another example of a class of chemicals. It sounds really good. You're going to prevent fires. But in fact, many of the flame retardants that were used, the concentration that they were in the products were not high enough to actually prevent the fires. You'd have to have more than, say, 1 to 5%. Maybe you'd need 50% of your material would have to be the flame retardants. And we do have now growing number of animal studies, mechanistic studies, and epidemiology studies where there are clear effects. But it's a hard communication challenge, honestly, Jason. When people, for example, I think you would agree, and I think most people, that lead is a problem. We know that early life exposure to lead is associated with IQ problems and behavioral issues and so on. Well, IQ at relatively low levels is associated with maybe a 3 to 4 to 5-point drop in IQ. You can't measure that in an individual. But in a population, if you shift the distribution, that has huge impacts.
So, would you say things are getting better or worse overall?
I think it's a really tough question. People will say, well, we're living healthier and we're living longer. Well, that used to be true. I'm not sure it's as true. There's a tremendous increase in chronic non-communicable diseases. So we now know that from pollution, according to the World Health Organization, 13 or 14 million people die every year. That is so many more people than die from infectious diseases. Think malaria, tuberculosis, HIV. So many more. And it happens every single year. Now, about half of that number is related to air pollution, and I think we're becoming more and more aware that low levels of air pollution have adverse effects on our health. Think of what happens when there's a forest fire. You're in the New York region. There were those forest fires a couple years ago. I saw pictures of what it looked like on the Brooklyn Bridge, that you basically, couldn't see anything. And we know that, for example, people with asthma end up with more asthma attacks. Now, can I say that your asthma attack on a day when there was bad air was because of the bad air? No. But on a population basis, we can see that there's an increased risk. So if you ask me, are things better or worse? Cancer incidence is still going up. Cancer deaths may go down because we're getting better at treating, but incidence goes up. Heart disease continues to go up. Obesity continues to go up. And it's not just people eating too much and being couch potatoes. And diabetes goes up. And a lot of these are associated or can be associated with chemicals in our environment.
Yeah, it's interesting. Environmental awareness has grown, exponentially over the last at least generation or so. But it seems to be largely centered, at least in my view, and I could be wrong, around global warming and the melting ice caps and things of that nature. And you tend to hear a lot less about the things that we're talking about today: chemical pollutants, water pollution issues, the plastics, air pollution, things like that seem to be maybe not getting as much attention as they deserve.
Well, I would agree with you totally. I think we haven't come up with a good communications approach to help people understand that the large number of chemicals to which we're exposed are impacting our health. A polar bear is very photogenic. And when you hear that the polar bears are crashing, people get upset. When people can say that there are no glaciers in certain places anymore, people get upset because it's acutely visible. But people don't understand that their cancer or their heart disease or their overweight or their type 2 diabetes may, at least in part, be driven by pollutants to which they've been exposed.
Yeah, I mean, it boggles my mind. You had mentioned earlier they're finding chemicals that haven't been made since the 1970s in every single human being they test. And yet nobody is talking about this. So yeah, we really do need to do a better job communicating and, getting this up there, I think, where it deserves to be in terms of public attention, up there with global warming, because why is it any less important?
Well, on a population basis, it's not. The average life expectancy has actually dropped in the past couple of years. Part of that's the pandemic, but part of it is these other kinds of things. We've in general have cured infectious disease. People don't realize that in 1900 in the US, the average life expectancy was about 40. Well, it isn't double that, but it's close to double that now. But you want to ask about the quality of life, and so on as well. And again, something that I haven't figured out a way other than being willing to talk to you, Jason, and other people and try to get the word out.
Which I really appreciate. And just one final quick question, because I know you have to run. What do you envision as really the key areas of future environmental health research? What really needs more attention? Does anything kind of come to mind?
Yeah, the fact that we live in a soup, that it's a mixture. I think this is the really important approach. It's very difficult. Some of us have been talking about this for 40 years, but it's a very difficult thing to do because your drinking water in Long Island may be very different than my drinking water here in North Carolina. Okay, so it's hard to look at that. And then it's not just your drinking water, it's your food. And I think we have to become more willing to extrapolate from what we learn from one situation to another. So we kind of know that if a chemical is very persistent, in the environment and in our bodies, we know it's going to build up and it will cause a problem. It's just a matter of time. Okay? And we need to be thinking about that. And then we need to be thinking if a chemical is not very persistent in our body, but we're exposed to it all the time, that may be a problem too.
Okay, well, Dr. Birnbaum, let's leave it there. I want to thank you so much again for coming on board today. Thanks so much.
Well, thanks for having me. Appreciate it.